Hey, welcome to our introduction for Welding and Metal Fabrication course 227. So this course we're going to start to develop flat patterns for metal objects, and we're going to look at exploring kind of three configurations of drawings, and they were known as like parallel line development, where you have sides that are running parallel to each other, and radial line development, where the sides aren't parallel to each other, but they meet at a common center, like a cone. Is a simple example of that. And triangulation, where we would use kind of a combination of parallel sides and sides coming together to define true lengths, and we'll use Pythagorean theorem. So in the future videos, we'll lay out some of those rules that we're going to use over and over again. For this one, I just want to do an introduction to this kind of work, and just briefly introduce, where this work came from. And we're going to use AutoCAD as a drawing template. And previous to this, we would have just drawn this on a drawing board. So something like this. I'm going to get out my highlighter here. And so, previous to using AutoCAD as a drafter, or even as a layout, even as a welder, when I would go to lay stuff out, I may employ a board to do drawings. This would have came in handy in first year to do a lot of our drawings, our orthographic projection drawings. And so I would use a T-square that would slide along the side of the board to do a lot of my parallel lines. And I can then use a number of triangles to make 90-degree angles or 45-degree angles, or employ another triangle that's not shown here, like a 30, 60, 90 triangle to do 30s and 60-degree angles, or to use them in combination with each other to draw all the angles I would need, and to draw things to kind of extract information. So this kind of disappears as we go to AutoCAD, and we don't use these hand tools like we would have used to. But I don't want us to lose the connection to this is what we're using AutoCAD space as our drawing board, and then we're just using the ease of the tooling in AutoCAD to take the place of all these tools that I would use. But in this course, we'll still take some of these ideas to our metal table in the fab shop and lay some of this out. I can use my fab shop table as my board table here. I can use framing squares and a combination of squares to draw this stuff on my table to extract patterns out in the fab shop floor. So I kind of like to make that connection, and we'll try to do that in our lab work. So we would have also used other tools. These sets that we would buy would come with typical drawing stuff like this, where I'd have a protractor to lay out specific angles, a compass to do all the circular work that you'd have to do. And then as you plot lines point by point to connect those lines, we like to have a various number of curves instead of being straight line from point to points. And you'll see what I'm talking about as we draw our own drawings. But we would use a French curve template like this to actually make nice smooth connecting points rather than just jagged straight lines. And much the same way you guys have used to draw stuff for the plasma cutting table, you like to have arcs and radiuses from point to point so that it's a nice smooth cut. And it's the same way when I hand lay stuff out. So I like to have stuff like these French curves to make those from point to point. And all right, so I kind of wanted to show you where some of the stuff that we're going to draw, where you would find it in the industry, and see it being used. And so I'm going to go through some slides here that kind of show, and I'll just talk you through what I'm looking at when I see these slides. So, and then in our fab shop, we use maybe something like this, that's kind of a hardened tip scriber, to draw circles on our metal, right? To actually etch the lines, to scribe a line on metal. And we have some of these hanging up in our tool boards out in the shop, so I can do my round work right on the metal. I think we have one that'll accept a pencil too, so you don't have to actually just scratch everything. You can actually draw with it too. So, and we'll use some of these tools as we draw patterns on our tables of some of the stuff that we're doing on AutoCAD. So, I found that we need to make that connection. Instead of just taking for granted that I always have to have AutoCAD to draw, I can actually still hand draw this stuff. Everything we're doing in AutoCAD really can be done with lines and circles, you know, using some more common tools. So, and then briefly, and this is one rule that we'll talk about, and we'll come back to this, but we're going to be dealing with a lot of round work, and you guys have rolled some round stuff on our sheet metal roll out in the fab shop, and so I'll come back to this, but when we do this and as we do our layouts, we'll need to sometimes take this into account if I'm making the part out of metal, that I've got to determine if I'm shooting for an ID or an OD dimension. And so I'm going to skip over this right now, but this will become important in the future, and I'll include it with some other rules as we go through the rule videos that we lay out first. So yeah, and so this is kind of one of the first drawings that we'll do in AutoCAD, and this one's been done by hand, but we're just going to draw a view of a pipe and at a particular miter, and make a template that he's actually already cut out here. Use the information from this drawing to make a flat pattern template that could actually be rolled around like this piece of pipe, and then it would establish this cut line here using a paper pattern. And this gets more and more complex as we go along, but I just wanted to show that this is actually one of our first starting points that we're going to do something very similar to this, and to the point to where it gets complex like this. And the idea here that I like looking at is that I don't know what the application of this particular part is, but we've got nice tight weld joints. These are coped to fit onto the center runner here. And they're coped really nice to make nice tight weld joints, which is what I'm always after as a welder. Is the better and more accurate my layouts are, the better my welds turn out when things fit up tight. And this actually shows from that previous example where it was just a straight mitered pipe. This one shows that it's a round meaning a round, and it has this like taper, which you couldn't cut this in a bandsaw. You would have to actually have this done as a layout or on a coping machine. So we'll learn how to like lay stuff out like this. It has this curved where a round part is going to meet another round part, so a round-to-round intersection. And so I like that this kind of showed that. It showed the nice tight weld joints, which is what makes me successful as a welder for my work to look good, and not like this. So here's an example. Here's a poor example of where some round-to-round layout work could have came in handy rather than just gob this up with welds. So this is not what we want to see. We want to see the previous slide, and what that takes is that's why we're learning this stuff here, so we don't end up a welder like this. And here's another like a round-around intersection. This is a branch test, and they use this test in the piping industry to test welders on layout and welding. So it's not just a welding test. This will actually be a layout test too. And there's tricks to this to figure out how to lay this out to make this branch. It's almost making like a big T. You know, this is in a case where maybe they don't have like a prefabricated part, and they do this in the field to build the T. So yeah, so we get to this on a smaller scale, but we can upscale this. I mean, AutoCAD's nice because we can go to the extremes and the maxes and big, and still stay at a really manageable work size. You know, so that's where AutoCAD has its advantage over just drawing by hand. Is I'd have to lay this out. I'd have to have a huge shop, floor to lay out really big fittings, and AutoCAD can kind of make that simpler for me by scaling. So here's another example. In this 8-week block in our lab, we have the option to build a forge, and so the inlet piping, gas inlet piping on the forge, come into a round pipe that meets the round forge housing, and this stuff is held in position with some hardware here. But where this little pipe housing meets the actual forge housing is a round-around intersecting pipe, and these are kind of off-center. So these can get technically tricky, and we have to kind of look at each one and kind of learn about it. But there's an application for it right there. Is a smaller round pipe meeting a big housing that we see here in our shop. Here's one taken to the extreme. These are parallel line developments, and they're using fittings, 45, 90s, 30-degree fittings, and figuring out the pipe runs in between. But here we have like a branch coming into a header, and this is at a particular angle coming off this pipe, and so this would all have to be cut out and developed. And over here too, kind of hiding behind this little kicker here, is other branches coming in at angles. And so that's even another complicated factor, is taking a branch and intersecting a header at an angle, but also figuring these like offsets as this one comes across and then turns back into parallel. You've got this piping offset here, and you've got to factor in, use triangulation to do this, to figure out how far from this pipe to this pipe are, and so we'll do some of that layout work. Whether it's done with fittings, as in this case, these are purchased buyout fittings, and we're running the straight runs of pipe in between them, or we actually are doing mitered fittings, just mitering the pipe to make this turn. I have options there, and so we'll explore those for this course. And here's a gourd elbow. So it's like taking the actual pipe and mitering it to where I turn. This one turns 90 degrees, so this is a 3-piece gourd elbow that's just made out of the pipe itself. And you see these on stovepipe fittings, maybe smoker fittings. These are used like all over the place. Pneumatic systems where they don't have to use, you wouldn't do a buyout fitting, but you would actually just cope the pipe and share. And so there's some rules to laying this out, some rules to figure out how to do this, and we'll cover those as we look into gourd elbows and drawing those up. And you guys had some experience with this last semester, rolling some of these up, and now we'll talk about how we actually draw these out. Here's a large example of a gourd elbow, kind of duct work, but this is maybe this is a galvanized material, and these guys are wire feeding this together. So this is made in several pieces to make this big piece of ducting. Looks like it has a angle iron flange on the end that's been rolled, which we have the equipment out in our shop to roll angle iron like this way to make a flange fitting on a big piece of duct. So yeah, that's a big application of the gourd elbow. Here's a squared around. So we take and this is more into the triangulation. The stuff we've looked at previous have kind of been parallel line development work, and here's triangulation development work where we actually have to look at this in a couple different views and kind of use a right triangle to define these true lengths. This has been bent up in a press break. So this flat pattern has then been press broke round on one end down to the single point here to make this is actually a rectangle to round transition, really common in ducting, but also in heavier equipment too. So let's see what else I got. Yeah, like here's something similar to you'd see at like Rayco Systems here in the area. They build systems like this that employ a whole combination of this kind of development work. We've got cones going on back here, cones to a round to another cone intersecting. This is kind of like a cyclone. Think of the Dyson vacuum cyclone separator. This is kind of what we've got going on here. Big ducting with, and this is pretty large scale. Actually, this looks pretty small, but this is, some of these systems are 20 feet tall. And a lot of the stuff's made out of 10 gauge, so kind of heavy ducting is all it is. Big air fans. But here's like a rectangle to round fitting, going from the rectangular fit up on a fan to the round ducting for efficiency, and then back into a rectangle to round on top, and then this thing would transition back to round. So here's a pant leg development. This is tricky development. This is very complex to lay out a one-piece to a two-piece pant leg, and so that takes a lot of work to lay that out on AutoCAD. And then back to another kind of rectangled around here, this hood supply. So we've got an air supply coming up in over a conveyor, kind of extracting liquids and oils off of a product and recovering that oil or water. And yeah, so that's just like a kind of a vacuum system to get in the food processing industry. So, but a lot of stuff going on here that we look at this course. Here's just a sheet metal slip roll, kind of like a larger scale from what we've got in our shop, and they're rolling a cone on this. So I like this, that we show once we've like learned how to like lay out and develop a cone, which we can either have them eccentric or concentric, and we'll talk about that when we work at cones, what the difference is there. But you have to have a roll that this thing will pivot down, and so that one end can roll tighter than the other. And it looks like they've probably made some adjustments here, because typically this is the smaller end of the cone. This would be a tighter to the top roll. This roll would be pushed up tighter to roll that tight, and then looser down here. So maybe they've made an adjustment here before this picture was taken. But to actually do this roll will be tighter on this tight end of the cone, and then looser on the loose end of the cone when they're actually doing the initial rolling. And as you adjust this, sometimes you adjust your roll to make up the difference, to fine tune it. So this picture's a little bit misleading, but yeah, you have to have a roll that can do this, to roll cones tighter on one end and looser on the other. So I thought that was interesting to see. Here's like just some tanks laying out in the yard here, round to round intersection here. So this is maybe a door access into a tank. Obviously you just can't cut these straight in a bandsaw or whatever. These have to be coped to fit. This is a round tank to a round pipe, much like a T, like that branch layout from the earlier slide. But here's an application of it, maybe on doors access on a tank. So here's a large scale cone in multi pieces. It looks like it's all been step broke in a big sheet metal brake to be able. You can see the step brake lines to actually break this up, and then they've developed this into a couple different pieces just because of sheet size. So that all has to be taken into account, and then flanged on the end. So this is large scale. Looks like they've got a rotator here to rotate this into position for ease of welding position. Yeah. So that's a really interesting picture. Big cone, big black iron cone. Smaller stainless steel cone here. Multiple pipes coming in, round around intersections, cone on the end, down to really small, big, large reducing cone here. So maybe a drain out the bottom, but or not necessarily. Could just be they're fed out the bottom and stuff incoming on the sides. But maybe some I don't know if this is exhaust piping or something. But we've got another cone. Small, cone, and then actually turning like a gourd elbow turn here. So there's a combination piece of a cone to kind of a gourd elbow to a specific degree here. I don't know, 30 degrees turn or something in 3 pieces. 1, 2, 3 pieces, yeah. So that can be handy for doing custom exhaust work or a lot of kind of custom piping. That's the end of my slide. So I just wanted to have a brief overlook at this stuff before we started drawing it, just to show you some applications of what we're going to look at. And they can get really complex and really hard. We need to start this really simple and learn some basic rules. So the next few slides or next few lessons will be setting up some rules that we're going to draw by that will apply for AutoCAD, and they'll also apply for hand laying these out on a bench or on paper. So yeah, we'll catch up with you then.